minute. Okay, one second. I'll- Okay, good morning, good evening. Um, yeah. So thanks, Shanmugh. As he mentioned, so I have around 12 years of experience, SQL and performance tuning, SQL DBA and performance tuning. Uh, so this is the total or outline of our course that we are going to discuss, and so the timings would be so IDC, I mean ISTRs starting at 7 to 9, so it will be, or Eastern, like it will be around 8:30 p.m. I believe. So we'll start, and the duration so around 2 months, like we are starting for, I mean, so we will be connecting these during the weekdays, Saturday, Sunday for IST, and Friday, Saturday for whoever, US hours, right? So coming to uh, whatever the prerequisites that we have, so if you are performance tuning definitely would be helpful. So even if you are developer, if you are an administrator, or if you are looking for a job opportunities, whatever it is, right? So if you learn performance tuning, at least basic performance tuning, that would be definitely an added advantage when you are planning or when you are searching outside, even for job change or even role change, so whatever it is, and that would be definitely helpful, right? At least if you have a basic understanding of the performance tuning, whatever, so these are the prerequisites. I believe that we all know, like I don't want to repeat, because you'll have to have an, so whatever Windows operating system, so you'll have to at least a basic understanding of the SQL administrator. Suppose someone joined, and if they don't even have the basic understanding of the SQL, so might not be helpful this tutorial, because what we are going to discuss will be a deep dive, right? So starting from basics to the advanced. So you will have to have a basic understanding of SQL Server and basic understanding on SQL DBA, at least, so a few DBA task or content, whatever, right? So if you have at least working understanding, working knowledge on or T-SQL understanding, so that will be an added advantage. It is not mandate that you will have to have a transact SQL or T-SQL knowledge, but if you have at least basic understanding like select, update, insert, so at least these, it would be helpful, because those are all I might not be able to cover. I'll just jump in, select and all. So we have, if you have a basic understanding what is select and all, that would be helpful. But if you have any questions or any doubts, you can stop then and there, and you can ask me. I'll try to cover whatever questions that you have. Okay, so this is a high level. This is a high level. Whatever the course overview that I would say, starting with SQL architecture, which is heart of the SQL Server. So, or uh, even if it is an Azure SQL or SQL Server, whatever it is, the base will be the same, right? So the base architecture would be same. So whatever flavors that you go, either it can be in on premises, or you can go to infrastructure as a service, or you can go to the cloud platform as a service, whatever it is, the base heart, the architecture would be same. So if you understand this, the you'll have to have a clear understanding of the SQL Server architecture. Then we'll go for execution modes, weight statistics, troubleshooting storage issues, like storage subsystem, query performance, then we will go with the query tuning, right? So these are all that we will talk, right? I might not be going each and every line here, but yeah, high level. If you already gone through, that is well and good. Otherwise, these are all things that we go, right? So for example, high CPU utilization that we talk, then memory architecture and internals, and concurrency, locking, blocking, deadlocks, 10 dB usage. right? So I'll maybe talk about always on performance issues as well, right? So let's say you see that always on configured and there is a lag between from primary to secondary, right? So if there is a lag, synchronization lag from primary to secondary, how you will start looking at what are all things that you will have to monitor, right? So what are the wait types that we have? These are all things that we will talk. And there are tools that we use to troubleshoot, right? So profiler, extend events, query store, so DMVs, whatever we have, so we will talk. And I'll show you different tools that we use to investigate the issue or troubleshoot the issue, right? So maybe we'll, based on the time that we have, so we'll try to cover the SQL Server 2022 feature with respect to the performance tuning, like, so whatever, if there is any improvement with respect to the performance, or if there is any, so added features in 2022 for with respect to performance tuning and or improve the performance. So we will talk all these uh, things during our uh, sessions. So if you have any questions, you can ask me. Otherwise, we will start with the architecture, and move forward from there. Right. We can give me a minute. Right. So let's move on. So what we were talking, this is a high level, so architecture, three tier architecture that I would say. Like, so here we have the so database. So this is where we are responsible to take care of, right? So let's say, for example, this is a client. So I can say, like, so you can consider that is a web page. So whatever web page that we have, it can be any web page, right? So Amazon, right? Amazon.in or Amazon.com. So if you open a web page, that web page has to connect to the middleware, that is an application server, to fetch the data. So application server will have a logic, right? So where it should be connected and how to get the data, right? So it can be in a Java based, or it can be so in a application that was written, or the logic that we have, it can be a .NET, it can be a JDBC, whatever it is. So you will have the logic to connect to the database and get the data and send it back to the client to display the result, whatever it is, right? So here, this is the database that we support if there is any performance issues, right? So let's say, for example, the web page is taking longer to load, right? So it can be an issue with the web page, it can be issue with the network layer, or it can be issue with the application, or it can be issue with the database, right? But the first thing that so everyone so blaming is SQL, our database, right? So we will have to check and isolate, or make sure that we should tell that either it is an issue with the SQL, or we don't see any issues at the SQL server. So that is what we need to check. So we'll have to isolate the issue, make sure that there is no issue at the SQL server, right? So this is where we will have to start working on. um okay. Okay, going back to the SQL Server. So this is what we were talking, right? So going back to the SQL Server architecture, these are all high level components that we have. I'll just open that. Right. Okay, so these are all high level components that we have. So we will have, so network libraries. So this is the first layer which every application or every application or drivers will be connected to, right? So we will talk that later. What is driver? What is that? So this is the first place we will have, and second one, user mode scheduler. This is what we called as an operating system. SQL operating system. So it is not the Windows operating system. So SQL operating system, because we will manage the CPUs. The SQL Server also will have to have that CPU processors and all, right? So that is something that it will be managed. So then we have a relational engine, uh, where, so the uh, other process like, parsing, everything will happen. So we have something called storage engine, right? So this is the logical, this is the physical. So what does it mean? So storage engine, where the data are stored in the memory, or the pages will be stored in the memory. Then down the line, so we have something called IO manager, right? So where you will have to interact to the storage and get the data, right? Because whatever you process, everything will be stored in the storage. Second, Windows API is your Windows operating system. So this is diagram with respect to the Windows operating system. If it is a Linux, or if it is, uh, any operating system other than Windows operating system. So this would not be there. It will be until this, everything will be same, right? Until this, the entire architecture, everything will be same. So now we will talk about whatever these in a bit, right? See, any questions? I see, so any questions? I see someone is muting himself. Okay, fine. Okay, let me go forward, right? So as I said, right, network libraries. So we do have mainly three network libraries, right? One is shared memory, TCP IP, TCP IP. Third one is one second, where you can see whatever like network libraries that we have. Shared memory, named pipes, and TCP IP. So I'll show that later in a bit. These are all network libraries that we have. So any application, right? So it connects. So application can be anything within the same server. It can be outside of the machine, or it can be anywhere, right? Connects. It should be connected through the one of these network libraries, right? So let's say, for example, that you have an application here sitting, right? So this is an app. This is your database server. So this application has to connect to the database, right? So this application, as I said, this can be any application. It can be a Java based application. It can be a .NET based application. Whatever application, it has to connect to the database server, right? So how this will be connected? Using some kind of drivers, right? So drivers is basically a communication channel, where it will be establishing a connection to database server, right? So there is a handshake between application and database servers through the drivers, right? So as I said, so shared memory, TCP IP, and named pipes, that three network protocols that we will have to have. So what is shared memory? So the term itself is saying like it is a shared. So shared is nothing but, okay, shared. Whatever. If application, okay, 1 second. Let's say this is your computer or the machine. So you have SQL Server application and SQL Server on the same machine, same server. So if both are in the same server, it connects through the shared memory, right? So both will be communicated through shared memory network protocol, right? So if this server, whatever server that we have, so if it is outside of the mission, right? So you have so somewhere like here the application and the somewhere like here, like it can be anywhere. So if you have a network in between, and if you have an application here and DB here, so these two will be, we should not be communicated through shared memory because shared memory within the same server. These two will be communicated, either it will be a TCP IP or named pipes, but I forget. Okay, named pipes protocol, network protocol, right? So these two will be communicated. But when we should use this, when we should use this, right? So you can consider that named pipes is a LAN communication, local area network. So local area network is a basically like, so let's say you have this within a shorter duration, a shorter distance, right? Let's say this is next to your building. Like you have this one tech park. This is nearby where these two will be connected directly through a LAN connection, local area network, right? So if these two are near, then the LAN would work, right? So because this is a communication where we can establish with. Whereas these two are very far. Let's say, for example, this is kind of, so you can consider that it will be in a in the USA. So the database server is kind of, so in India, right? So still, so if you wanted to connect using the LAN, right? So let's say, for example, how this will work. Even TCP also, it will be a wide area network, right? So if it is very far apart, right? It is kind of, different country, and this is in a different country, or this is in a different continent, this is in a different country or continent, right? If you want to establish a connection, so you will have to have a wide area network, right? So even what is wide area network is nothing but some small, so connections of a LAN. Let's say, for example, you have a network switch here somewhere, right? You will have a hundreds of LAN connections here around, kind of thing, right? So these LAN or these another switch, let's say you can have another switch here. This is another switch. This is a central hub switch. This is another network switch I'm talking. Switch is nothing but a connector to your servers. This is another switch. You can consider this switch is connected to n number of other switches or n number of other LAN connections. This LAN connection will be connected to your server. This LAN connection is connected to your switch, and this switch is connected to your centralized switch, right? So that is how the wide area network connection will be established. So wide area network connection is nothing but small local area network connection, but it will be maintained within the centralized hub or a centralized switch that we have, right? But named pipes is directly connected to a LAN connection. So the server is connected to a LAN and it will be working. But if it is a TCP, if you are using a TCP IP, it will be using a wide area network so that the network will be established. The connection will be established across your application and the database or wherever you have. So it will be established. Okay. So this is what the network library is. So this is very important because if application is using, I'll just clear this up. Let's say you have an application here and you have a database here. So how this helps, right? So let's say, for example, you are using an application named pipes. So named pipes network protocol. So if you are using a named pipes in application layer, the driver will be communicated, whatever I told, right? So driver will have a logic to connect to the database. So in the in the driver that we will provide that the information like what database, what server that you'll have to connect and all, and that will be connected. So instead, so in the application connection string, you will mention that okay, this is a JDBC driver, then server name is this, database name is this, right? So in the application, you will mention that, okay, use the JDBC driver and connect to the database and server. So then JDBC driver that you will have to install, right, in the client drivers so that it will be establishing a connection between the two parties, right? Now, let's say you are using a named pipes and up database side, let's say you are using TCP IP, right? So if you're using a named pipes at the application layer, and if you're using TCP IP, the driver will be refused to connect, right? So the driver will not establish or make a connection to the database because these two protocols are different, right? Suppose if you're using a named pipes here, that you will have to use named pipes here as well. So if you're using a TCP IP, and you will have to use TCP IP here, right? So this is how that you will have to provide, right? So again, TCP IP, you will have to provide an unique IP address, right? So the IP address, I mean, not you will need to provide. So it will be taking an IP address and it will be connected to the specific server. So what I mean, let's say you have an XYZ. You have say ABC as a database. ABC underscore DB XYZ is an app server. Now let's say in the connection string, so we all know we are connecting to the database using the connection string. So that connection string will have the information. What information you will have? Yeah, anyway, you will have the driver details and all. That is a part of that. You will have the server name. Server name is ABC underscore DB. DB name equal to, let's say, DB1. Now, this one you have, right? So ABC underscore DB. This is your database server. How this application connects only this DB? Because this is going through the TCP IP. So what it will happen? So whenever you have this server details, so internally, this will be I mean, so internally, what it will happen, it will be converted. I mean, it will be resolved with an IP address, right? So whatever IP that we assigned to the server, so whatever IP assigned, so it will be converted into the IP address, and then that IP will be searched in the DNS, domain name system, right? So in the DNS. Once we get the IP from the DNS, I mean, so here initially that it will not be it will not identify this, right? It will connect to the DNS, will not get the IP. Sorry about that. So I'll take my one back. So whatever server that we have, it will be connected to the DNS, and in the DNS we will define the IP address for each database or each server. So that will be resolved using the TCP/IP protocol that we use. So that will be resolved with the unique IP, because this ABC underscore DB can be n number of times. This is not unique, but whatever IP assigned to this particular DB will be unique. So that IP will be resolved once it is reached. The connection will be reached to the DNS server, right? That is a backend. It will be taking care if you're using TCP IP protocol, because the TCP IP we require a unique IP address. So that IP address, how this will get? It will get from the DNS server. So once that is received, then it will establish a easily connect to the destination server using the unique IP address. Let's say 10.10.0.0, whatever IP address that we have. It will be connected to that particular destination. Right. So this we no need to know, like, just a high level I mentioned for you to understand, like, so TCP IP. So it is a resolving with an IP. Yeah, Sridhar.
Hi, Chindu.
Hmm,
I have small clarification.
hmm,
For example, considering an application like PhonePe,
hmm,
I'm a user, okay?
hmm.
If I'm a user, it will be obviously TCP IP. I cannot use named pipes and other network libraries. Is my understanding is right?
Not specific to user, it is specific to an application, whatever user it is, and application wants it to connect. So this is at the application layer. So the protocol should be. It is not specific to any of the users or anything.
Okay. In case of like administration or whoever is working on application database, this particular network libraries comes into picture.
Uh, uh, no. Like, so leave about the user perspective for now. It can be a administrator, it can be a developer, it can be just a stakeholder, or it can be user. Doesn't matter. So what I mean, so let's take your example. You mentioned that whatever application, it can be Amazon, let's say, right? So Amazon.com. Okay, so you want to establish a connection. This is your, for example, DB server, SQL, right? So SQL DB. It doesn't matter whatever user it is connected to. So this application in backend, it should be connected to your server, right? I mentioned this web page, but just understand this is a application for your for us to easily understand, right? So let's say we need to establish a connection. So how this connection will be established? So you will maintain, I mean, application layer. It's nothing with the user perspective. So application, you will have to use a some network protocol, so that the network communication would be established between the two different servers, right? This network libraries can be a named pipes or can be TCP IP. Let's say you are using TCP IP at the application layer, right? So this is an application server. Let's say this is an application server. I mentioned this Amazon, but Amazon in backend, like, it is connected to some application server. This application server, we will have a one protocol, network protocol, so that it will establish a connection to another server through network. So we are using TCP IP. So in the database layer also we should use the same TCP IP. So this is at the back end, it will be taking. So you will not need to provide anything at the user or connection layer or anything. So if you application is using this TCP IP and the connection at the database, I mean database network layer also, we should use the same network IP, same network protocol. It is not nothing to do with the specific to I mean, specific to user. For example, if you are talking about the SQL also same, right? We are not using at any specific user or anything. So we are configuring at the SQL layer. So how you will configure? If you go here and we have three protocols. One is shared memory, named pipes, and TCP IP. Likewise, application also will have somewhere they will be defining. So where they will have to use on which protocol. So it's not nothing specific to any user or any administrator account, anything.
Okay, Chandra.
Is
Thank
it clear or any still confusion?
you. No, let us, the point here is, for example, now we are connecting through SSMS, okay? We
Hmm,
may be remotely connecting if it is not shared memory, like we installed SQL Server, some version, and with
hmm,
this in the same system, if we are installing SSMS to connect, it will be using shared memory.
hmm,
This concept is clear.
hmm,
Okay. Again, in two different systems, yeah, with a different server. One server is installed with SQL Server
hmm,
instance,
hmm,
and we are connecting from different system or client. Then
hmm,
it will be obviously if we enable TCP/IP, we can make an TCP/IP connection establishment and we can communicate.
hmm,
This concept is clear,
hmm,
but my concern is, obviously if I'm a user other than administration, developer or tester, whatever it may
hmm,
be, who are
hmm,
interacting direct through SSMS or different type of communication, could not be a SSMS.
hmm,
We are as a point of administration we are working, that is okay, I am clear about that point.
hmm, hmm,
My concern is if like I am a user, I am not into admin part, I am using some application.
hmm,
In that case, definitely other we my point is I should be using only in TCP/IP because I'm a remote user, I'm not into that system.
hmm, hmm.
Is that the statement is right, or it's
Yeah, yeah. So, I mean, so understanding is anything, but like, so whatever application that uses in backend, it will be using whatever one of the two protocols. What I said, like TCP, like, so if it is an named pipes, it will be a local connection. If it is a, so a wide area, like you will have to use this TCP IP. But yeah, so whatever you said, that is correct. Like you will have to use TCP IP protocol that is a wider area so that even if it is very far apart, so it will be establish a connection to the database.
okay? Thank you.
Sure. Okay. Right. So that is you will have to use so in the application layer and the database layer, you'll have to have a same protocol so that it will be established. The communication or handshake easily established so to proceed further to make a connection. So user mode scheduler. So after this architecture, we will have a detailed discussion like, so what is this user mode scheduler and how that helps, right? So, and all we will talk about it. Now, coming to relational engine, right? These are all components that we have in the relational engine, right? So uh, we will talk this in a bit. So we have a storage engine. So the connection between relational engine and storage engine. So these two should be communicated. Why? I'll talk. So through the OLEDB provider. So again, this is another OLEDB driver or provider, whatever we call it as. Like application and the SQL will be connected through one of the network drivers, right? These two, the relational engine and the storage engine, will be communicated to another provider so that another OLEDB driver or provider so to establish a connection. So these two should be communicated to proceed further execution of your queries, right? So I'll talk what is this relational engine and I'll talk what is this storage engine and the IO manager. Let's take a simple example of your any one of the queries, right? So I'll show you or I'll talk how that helps. Let's say, for example, you want to execute some select statement, select star from table. It is just a simple select statements that I'm going to execute. So how this works? So with respect to the architecture that we have, so how this works, we'll talk, right? Let's go with this. Mm, 1 second. Okay, fine. Mm. So as I said, right, here, let's say this is your application or user connected, right? So this application, we will have a network layer. It, as I said, right, it is a protocol layer. It can be either named pipes or the TCP IP. So majorly the majorly we work or enable TCP IP protocol. Let's say this is your application layer where you have the network interface, server network interface. I'll just add this here. Application. So application, we have a SNI, server network interface, right? Application layer, we will have one network interface. At the same time, so database layer will have another SNI, server network interface, SNI. So what is this SNI, server network interface? That's what I was talking, right? It is either TCP IP we should use, then named pipes, but we use TCP IP, right? In the server level, we use TCP IP. In the client level, also we use TCP IP. So this network interface, server network interface, what it does, right? These will be communicated through the network, right? So this network doesn't know what is select, doesn't know what is this statement, right? You cannot directly send whatever plain text from the network, right? So you cannot send this through the network. So what this work, SNI, server network interface job, is to divide or is to convert this select statement into multiple network packets. That is what we call it as a tabular data stream, TDS packets, right? Whatever. So TDS network packets, it will be converted into TDS network packets. So based on the query that we have, based on the, so the size of the query and all, like, so that will be converted into multiple network packets. This network packet will be sent through the network to the server network interface at the database layer. Okay, DB server. This is the DB database server. This is an app server. We are using SNI. So SNI's job is to send network packets, right? So say SNI responsibility is to convert whatever user is input, whatever user's input, it will be converted into TDS packets, and those TDS packet will be sent to the network layer at the SQL server or the database server. Then and this SNI server, SNI layer, server network interface at the SQL server or the database server will unwrap this. This is a wrapper, right? So TDS packets are wrapper, right? Wrapper is nothing but it is wrapping around as a TDS packet. This will be unwrap this, right? So unzip. You can consider that zipping, unzip as a zip file. The same thing, TDS packet, it will be unwrapped as, and it will be converted or it will be unwrapped and send this as a unwrap this packet and converted as a plain text, right? That is what it is, right? So we will send a TDS packet, and that TDS packets at the protocol or server layer, it will be converted. It will be unwrapped, whatever TDS packet, and it will be converted as a language event. So what is language event? It can be select, whatever, update, whatever that we have, it will be sent to the relational engine. That's what I was talking, right? So relational engine in the previous section, I said I will talk in a bit. So this is where the relational engine. So in that relational engine, we have the main components to proceed with your execution. Remember, this is relational engine is the main thing in your performance, right? So whatever performance that we see now, the improvement, everything is based on, majorly based on the relational engine. Definitely the storage engine will be used, helpful, but relational engine is the main main thing in the SQL Server to perform your operation faster, right? Let's go understand what will happen once the SNI sends the language event or converts the TDS packet into the language event. As I said, select. Then it will go to the command parser, right? So command parser we have here, right? I'll just try to draw so that it will be easy for you to understand, right? So let's say there is a select, right? Select is sent to command parser, right? So what does it command parser do? So whatever query that we have, it will validate this query syntax is valid or not, right? So the query syntax is correct or not. The command parser is just responsibility to validate is the query syntax is correct or not. For example, if I go here, um, connect database, whatever it is. So I'll just stop this. So what is that command parser does, right? If you see here, the so check mark, this is what it is, parse. That is what you see, right? It is parsing. So the same thing, it will do, it would be happening in the backend whenever the event, language event is sent to the command parser. Command parser, what it checks, whether the query syntax is correct or not. For example, let's say this is what my table, my query. Let's say test, anything, right? Select start from test. So though I see this one line here, because this is a invalid object. The object is not exist. But if you just try to parse, it will not give any error because this is not a command. This is not a parsing error. Parsing is nothing but it will check the syntax, syntactical error, right? It checks if there is any error, syntax issues or not. If not, then it will proceed further. So this table exists, not exist, that doesn't matter. It will check the syntax is correct or not. For example, select start from test, right? So if you execute this or if you parse this, it will get an error, right? The reason select is not this is not a, syntactically there is an error, right? This is not a syntax for select, right? So that is where we get a error. So this is same thing that it does whenever the language even sent to the command parser. Command parser will validate if the syntax is correct or not. So there is another step it does is once the syntax is valid, right? Once the syntax is valid, then it will further go to the algebraizer. So algebraizer, I mentioned somewhere here, right? So you can just go this, right? So whenever there is so whenever the parsing is done, right? So as I said here, this is the query that you are executing and it will check validation and all. So once the validation is completed, then it will go back to the algebraizer. So algebraizer is nothing but it will check whether my query that I'm executing have an object, has an object, or whatever query that I'm executing. Okay, 1 second. Suppose the same thing you take, select star from table, right? Select star from test dot table, right? These two are different, right? Agree? Because if it is executing this, by default, it is going with a DBO schema, right? By default, it is going with DBO schema, right? So if I use this, it is going with test schema, right? Schema is a basically logical, you can consider that container of that particular tables, right? Container as in, like, for example, I want to uh, have, let's say, for example, I have a HR department, right? So I need all tables belongs to HR should be in a single representation, right? So single, so kind of, so container representation, for example. Then I can mention that I can create a schema, HR schema, and I can add every table that I wanted to add in the HR department to that particular schema. And I can grant few users under that particular schema to access, and I can revoke others to access that schema. That is a different topic altogether. But if I talk about algebraizer or schema binding, I would say it will check what is whether table exists. If the table is exist, what schema that is, right? So that it will go further. Based on that, it will generate a based on that, it will proceed further execution, right? That is what it does once the query is parsed. Once the query is parsed, it will go for query binding, right? So it will check that, so whatever the schema we have, whatever the table that we have, whether the table exists or not. So everything will be taken care using here, right? Go back here. Then once the schema binding is done, where is that? Once the schema binding, the parsing, then it go back to the binding, right? So once the schema binding is done, then it will be created, converted this query into a query tree. Once the schema binding is done, then what it will do, it will be created a query tree. So this is all happening. You can consider under a query parser, command parser, right? So command parser. So you will have a algebraizer. So it will validate if the schema binding is there or not. Then it will convert as a query tree. Query tree. What does it mean by query tree? For example, that I have a select. So it will be converted like a tree-like structure, so that it would be easy for optimization, right? Let's say, for example, I want to select. This is simple query, but if you have a select, then it will be checking like how many objects that we require, how many tables that we have. Let's say this is a test table. Suppose if you have multiple joins, multiple things, whatever it is, it will be converted as a multiple small pieces, right? Like a query tree, right? It will be converted as a query tree, so that the optimizer, or I'll talk about the optimizer, but query tree, so that the optimization would be faster, because you no need to you no need to execute entire query at the same time. I mean, you no need to proceed the optimization with the entire query at the same time. So if you break this query into multiple pieces, right? It would be easy for optimizer to generate a optimal plan. So that will be internally taken care, right? So it will be converted. I mean, piecing, it will break as in like it will not divide here and there. Like it will be created as a query, like a tree-like structure, and that tree will be sent to the query optimizer. right? So the tree structure will be sent to the query tree, right? It will be sent to the query optimizer so that query optimizer will understand, okay, I have this query. This query has these many tables. This query has these many joins. This query has these many, so come columns that is required. So everything will be available, right? If you just send the query entirely, the optimizer task is to understand, analyze this would be difficult. Before that, the command parser or the algebraizer, whatever I was talking, it will be converted this query into multiple bits and pieces, like multiple as a query tree, and the query tree will be sent to the query optimizer. This is very important. Query optimizer responsibility to optimize the query and generate a plan, right? So plan I will talk. So the query optimizer responsibility to is to generate a optimal plan, right? What does it mean by optimal plan? This went to optimizer. Query optimizer, right? QOP adjustment है. Query optimizer responsibility is to generate a good or optimal plan. I wouldn't say that good because I'll tell you. Query optimizer will generate an optimal plan. So before even generating an optimal plan, what it does, let's take one example. Let's say you are something like, so you're constructing a house. Let's say just simple example. You're constructing a house, right? For the constructing a house, you gather some information. Let's say, for example, the cost for construction, cost for construction, house construction, house building construction, whatever it is, labors required, like how many members required to construct the house, right? Whatever material you require, spelling, okay, whatever material that you require for the construction, right? Everything you will have, the design, interior design, exterior design, whatever design that you have. So you have everything. So what we all this called as a plan, right? You will have a house construction plan. Now you have a plan, right? Let's say you given your house construction to a builder or a engineer. So engineer is creating a plan, right? That plan is a gated community. Let's take an example. It's a gated community house or construction, the villas you can consider and constructing. Now let's say you have one villa constructed here, right? I would say like, so constructed. For this constructing a villa, the engineer designed a plan, right? The plan consists of everything, right? The estimated cost, the estimated number of members required, and estimated material. The actual can be different. The estimated material, whatever it is, and estimation, everything will be estimated and generate a plan. Before even constructing, I would say, I'm telling. So before even construction started, the engineer will plan this. Now, for the second house within the same gated community, he no need to create a separate plan unless it is required, right? So these two should be identical. Let's say, for example, based on the gated community, every villa should be identical, right? So let's say just an example, because there are communities where everything will be identical, right? Then the plan cannot be regenerated. I mean, you can reutilize, like he can use the same plan, right? Why wasting some amount of time creating a new plan for this house construction? So same house, same model, same building, same thing, everything same. Why you need to create another plan, right? This plan can be utilized. The same plan can be utilized because everything would be same, the cost, everything, right? The plan will be utilized. And later, someone wanted to have a customized or different villa altogether, right? Then this plan cannot be used. The same plan cannot be used because that they want some customization. They want, so uh, two floor building or three floor building. They don't want villa kind of thing, right? If that is the case, this plan cannot be used. They will have to create again. Engineer has to create a new plan for this particular construction. The same logic you can consider for SQL Server optimization. Here, who is engineer? Query optimizer is the engineer, right? For the SQL Server, whatever query that you are executing, right? So query optimizer, before every query that you execute, before even proceed further, it will check whether I have a already plan exist in the memory, right? Where this plan exists again in the storage engine. I will talk that in the storage engine a bit later, but every query that we execute in SQL Server, it checks whether I have a existing plan or not, right? If the plan is exist, so where this plan exists in the storage engine. So storage engine, it is connected using the OLEDB provider, right? So that is another driver which will be communicated within the SQL Server. That internally takes care. We no need to worry about the drivers and all. It checks whether the plan exists or not. If the plan exists for the query, again, like, so you have the two identical villas. Same thing. If I execute the same query again, the plan can be reutilized. The same thing happens here, right? If the plan exists, the query optimizer responsibility is to take the plan and go for execution, right? Take this plan and go for execution. Now, I will talk if this is the scenario. Someone asks for customization. Let's say I don't have a plan exist. Let's say I'm using select star from um, or I'm specifying. You all know, right? So star is basically uh, for all the columns in a table that I wanted to get, right? So that is the reason we use. Now I want only a certain columns. Select name, comma, ID from table, right? This is little clumsy, but yeah, just try to understand so that everything will be here. So I am using this query. Now the query also changed from here to this to this, query changed. So the same plan cannot be used. This plan should be regenerated. So whatever the query, whatever the columns that we require would be less because select star, it has 10 columns. Let's say you require only two columns here. The query is changed and the plan, the estimation will be changed and the plan will be changed, right? So that is what it is, right? So query optimizer is basically checks if the plan exists. If the plan doesn't exist, then it will go for further optimization, right? So in this optimization, so far is clear or any questions? Okay, so if you have any questions, you can raise your hand and I'll try to answer. Okay, so the query optimizer's responsibility is to provide or give the optimal plan. I'm not saying that best plan or, whatever it is. The reason I'm telling, let's say, just that. Query optimizer responsibility is to generate an optimal plan because the plan generation, to generate an optimal plan, SQL Server internally calculates hundreds of permutation and combination, right? Hundreds of permutation and combination to see what is the best plan. So what is an optimal plan for this query to execute? Suppose, let's say in the 10th, I'm just taking these numbers, but this is not hard coded and don't consider only these things. Let's say 10th iteration, it identifies an optimal plan. Then it will stop then and there. The further optimization, it will stop then and there and generate a plan, right? It generates a plan. In case, let's say, for example, even let's say there are many permutation combination is happening, like, so SQL is not able to generate an optimal plan, then whatever plan it feels, whatever plan the query optimizer thinks it is an optimal for this query, then the further optimization will be terminated and it will be providing a it will be generating a plan, right? It will be generating a plan. The reason for this, let's say you have a very complex query. Just take an example, very complex query. And what if query optimizer couldn't generate an optimal plan within a few milliseconds kind of thing? Like the plan generation should be very fast. If it is not able to identify or generate a plan within few milliseconds, if it is keep searching for the best plan, the reason I mentioned that it is not best, it is a better, it is an optimal plan difference. Optimal plan and the best plan is different. Optimal plan, whatever plan is optimal, whatever optimizer it thinks this is an optimal plan for this query, it will terminate the optimization and generates a plan instead of searching for the best plan for this query, right? If it is keep searching for best plan, the optimizer will never end. So it will keep on looping and searching for best plan until it gets. So that is not happening in query optimization. It will just check whatever optimal plan for this particular query at this point, then and there, like, stop then and there, and it will generate a plan, right? So this is the optimizer first responsibility. Now, what what are all things optimizer actually does? Yes, Ridhar.
Chindu, optimal in the sense, depending upon the resources which are available at that point of time, considering those available resources, it is going to prepare the plan. Is it the idea is right?
Correct, correct. That is true. That's what I mentioned here. Whatever this is all for the that's I'm going to talk next, like what query optimizer actually does. But this is what it is, right? So if it is a house construction, how you are getting all these things, the SQL server also it will check what are all resources that we have and everything. Based on that, the optimal plan will be generated.
Okay.
Right. Yeah. Your understanding is correct. The optimal is nothing but whatever resources, whatever everything, right? So whatever we have, so based on the resources and all, that generates an optimal plan. Now, so what is this optimization? I'm going to talk now. Let's say you have a simple query. I'll just go with another. I'm talking about the optimization, right? Let's say you have a simple query. Let's say. So optimization actually happens in multiple phases, right? Phase 0 starts with phase 1, phase 2. Let's say it can be more phases also. But majorly it will be happen in 3 phases, right? Multiple phases, whatever. In phase 0, what happens? Let's say you are executing a simple select query. Select star from table, right? See, it is just a simple select query. Does it require any of the resource? I mean, it might be required resources, but that is different thing. Does it require an optimization? Because this is just a simple select query. So what optimizer thinks that, okay, this is simple query, or it will be considered as it is a trivial plan, right? So it is a trivial and executes, I mean, a trivial and stop further optimization because it doesn't require a spending more time on this, right? Either it can be scan, table scan, whatever. I mean, we will talk that later, but you are executing a select star from table, simple table, one table. You're executing and getting all the data, all the columns, and it doesn't require further optimization. So here stop then and there and consider that as a trivial plan, and it will stop further optimization. Take an example. I'll just show you, but don't worry about it. Create table test ID integer. Just creating a table. Select star from select star from table test. So, as I said, this is nothing complex, right? If I execute, I will talk about this whatever I have shown, but I'll just show you this in a high level. Um, right? I'll go to properties here. If you see that optimization level, it says that trivial, right? So it says that trivial plan. So trivial is nothing but it's not a complex. So optimizer thinks that, okay, this is a simple select star from. I no need to spend more time. So I will stop then and there and consider that as a trivial plan, right? Okay, so it is considered as a trivial plan and it will be proceed with this. Now, let's say you have, so kind of, so complex query. Let's say, for example, select star from table or select A, uh, ABC, whatever, right? So where ID equal to 100, order by, whatever, like, so you have a little complex query. This is not complex, but I'm just telling if it is thing. In the phase one, what it does, it checks whatever so table that I'm using, right? If it is a multiple tables and each table, how much data, like we call it as a cardinality that we will talk later. But what is the data that we are using? What are all joins that we are using, right? So joins that we have, let's say we have different types of joins, right? So what are all types of joins that we have? So everything will be considered and how much resources it is required for this particular plan, for this particular query, right? Resources as in it can be multiple. It will be multiple. Resources as in one is how much data this has to analyze, right? This will be analyzed. How much data I will say that estimated data. How estimated data it requires to execute, right? So based on this estimate, so estimated, I told you, right? When you are constructing a house, the engineer will estimate the cost or estimate, how many members you require to construct, how much, what is the design and all estimation, right? Here also for this query, it will estimate the data, the rows, or how many rows it has to read or proceed further. So everything will be estimated. And how much, based on this estimates, how much IO is required, right? IO, we will talk that input, output, storage and all. How much CPU might be expecting. So these are all estimated again. So how much CPU might be required, how much memory is required. These are all resources. The optimizer will be estimated internally during multiple phases. So these are all estimates that will be optimizer estimate while generating a plan, right? Then this will be proceed further, right? In the phase one. So the resources, whatever we have, it will be estimated. And based on that, it will be generated a plan. In further phase two. So phase two, in addition to the phase one, right? Whatever you have, it will be checking. Along with that, you have, let's say, for example, views, right? That you are executing, or you have something called indexes, what index it should be going for, right? Let's say, for example, I'm using, simple whatever table that I'm executing, what index it requires, right? So that it will be helpful in optimization. Let's say I'm executing select query. If it is going for scan, right? So select a cluster index scan. We will talk about the operators, whatever the I'm talking now, but understand that it requires an in index that will analyze, the optimizer will check, or the optimizer will understand, okay, this query may be better, right, if I use this index. That analysis, it will be done optimization during the optimization phase 3, phase 2, right? It will be checking the indexes, whatever indexes that we are using, whatever the where clause that we are using, whatever the order by clause that I'm using. So everything will be analyzed in different phase, next phase, to generate an optimal plan, right? So in the phase 0, it will check and trivial plan and it will terminate the optimization. In the phase 1, it will check whatever the resources that I'm using. Based on that, it will generate a plan. Phase 2, along with the resources, it checks which index is an optimal for this query to go further, right? Let's say I'm using the seek. So then I have a seek index. Non-clustered index or clustered index. So if I use this index, it will go for seek, right? Then optimizer will go for optimization and generates a plan. I'll be going to talk about whatever seek scan I'm talking. Just understand, it will be using the index so that the query execution will be much more faster, right? So this is the different phases and it generates a plan, the query plan, right? So once the plan is generated, the estimated plan, again, the query optimizer is always generates an estimated plan. So it's not an actual plan. So this is all estimated plan. Once the plan is estimated or the estimated plan is generated, the estimated plan will be sent to the query executor. What does query executor does, right? So query executor start executing the query, right? So query executor, it will start executing the query, and during the execution, let's say, I'll just close this. Now I'll just insert something, insert into. So I'm just use this goal, it will be inserting into 100 rows, right? Now, if I execute this, I'll just, so use the, oh, okay, whatever. So if I execute, I got 100 rows here. You can see here, right? 100 rows that I get, right? So I am getting this. As I mentioned, query optimizer generates a plan, but where I will get the data from, right? That is what here. Once the query executor start executing, with the help of OLEDB driver, the request will be sent to the storage engine. As I said, storage engine is the physical data it stores, right? Then the OLEDB, whatever OLEDB provider query executor connects to the storage engine, right? This is the communicator. But in which place the storage, the request will be sent to is your access method, right? So is your access method. So access method is basically a, you can consider that is a middleware, or where it is a connector between query executor and the storage engine. So this is the net layer which will be driver which will be using to connect. But access method should, someone should receive, right, the request in the storage engine. So access method is a receiver which the request comes from queries executor. The access method got the request, then the request will be sent to the buffer manager. Whatever access method receives the request, it will send to the buffer manager. Buffer manager is the responsibility. Buffer manager is basically a manager. Managers or responsibility is to check whether whatever data that we have in the memory or not, right? So what I mean, whatever data that we have, so you might know whatever we store in the SQL server, it will be in the pages, right? I'm not going to talk about the page architecture and all, but whatever data that we have, I'll just give you a high level overview, right? So this is your, so file, you can consider the data file or MDF file. So in this data file, you have something called an extent, right? So extent is 64 KB extent, right? So in this extent, collection of pages, extent is basically a collection of pages of a collection of 8 pages, right? So let's say I'm just 3 pages only, but it will be the extent. Every extent will have a 8 pages, right? Let's say it is an 8 KB of each page, right? 8 KB of each page, so it will be 64 KB. So whatever data that we store in MDF or NDF data file, primary or secondary data file, the data will be stored in form of 8 KB page, right? So this is the smallest unit of our storage, right? 8 KB page. Whatever operation that we perform, it will be performed with 8 KB page, right? The same thing whenever there is a request from the query executor, I need 100 rows, right? So I need 100 rows for this query to satisfy. This 100 rows, or let's say 10,000. This 10,000 based on the size of the data, right? So if it can fit into a 8 KB page, or it can split, or it can be placing in another page. Let's say this 10,000 rows data, it is split across 5 different pages, 5 pages, right? Now, whenever you execute select star from table, right? Whenever you execute select star from table, it checks how many rows you require. Since you don't have where condition, because I am not specifying anything how many I require. I am just using select star from table. That's it. I require entire table data. Then it feels that, okay, I need entire data. It is split across 5 different pages. The data is in 5 pages, that I need all the 5 pages, right? That is what it does. So access method connects to the buffer manager, and the buffer manager checks whether the data page is available or not. So what does it mean? You have 5 pages, right, for this data. So every time if the query is connects to the storage and execute storage and pull the pages, it would be an expensive, because the storage accessing storage every time is an expensive. So instead of accessing storage, what it will do, all these 5 pages for during the first execution, it will be stored in the memory, right? So it will be stored in the memory. Reset. So everything will be stored. All the pages, whatever required, it will be stored in the memory. That is what we called as a data cache. So everything will be stored in the memory. Everything as in, like, whenever you execute a query, it satisfies some pages. It requires some pages before even, every time you don't need to access the storage. Storage is nothing but your disk. Whatever data files, MDF and NDF files are stored, You no need to access every time. So instead, the buffer manager, it stores the pages in the data cache so that it will be reutilized. The pages will be reutilized if it is stored in the memory. Let's say access method send a request to the buffer manager. Buffer manager checks whether the pages available in the cache or not, data cache. If the pages are not available in the memory, the buffer manager responsibility is to get the pages, connect to the so data file and get the pages, and it will the buffer manager save the pages or store the pages in the data cache, right? Understand? First, whatever query that we process, everything will be processed through the memory because the memory is the fastest to execute. What is our main goal? Whenever we perform any operation, should be faster, right? When that will be faster, if it is there in the memory. If it is not in the memory, every time it has to access to the storage, then it will be late. It will be slow, right? To avoid that, buffer manager will store the pages in the data cache, and from data cache, the data will be retrieved. What if the pages are not available first time you are executing, or you whatever the data in the memory is flushed out, right? You restarted the SQL. So if you restart the SQL, whatever memory we have, whatever temporary memory is always temporary, right? It will be flushed out. Same like your mobile phone, right? If you just your mobile phone, like whatever recent apps, everything will be in the memory, right? So that it will be faster while accessing. Suppose if you force quit or force close the one of the apps, next time if you are opening the same app, let's say WhatsApp, if you open the same app, it is taking time. The reason it is taking time, it is not in the memory, right? If it is in the memory, if you open the same app second time, it will be faster. The same thing happens, like even if you restart your mobile phone, right? Whatever temporary memory objects we have, whatever temporary apps that is running in backend, everything will be flushed out. So whenever you open any apps, it can be a camera, it can be photos, it can be WhatsApp, Snapchat, like you open any apps, that it takes time because that is not in the memory. The same thing applies here as well. If the pages are not in the memory, it will be in the disk, then the pulling data and keeping into the memory would be taking time, right? That is buffer manager's responsibility is to get the page from the disk and store it in the data cache to proceed further. Once the data is available in the data cache, then we buffer manager pull the data which is required. It can be 5,000 rows or it can be 10,000 rows. It will pull the data and send it to the access method. So access method will send the data set. Data set as nothing but whatever data that we pull, it will send it back to the query optimizer through OLEDB provider. That is where we have down arrow and upper arrow. So query optimizer receives the data from the access method, right? Then what query optimizer does, it will send it back to the SNI layer in the SQL server. It will send it back to the server network interface layer within the database layer, database server. What it does, again, the same story, it will wrap whatever the result into multiple TDS packets, tabular data stream network packets, and it will send it back to the client. In the client side network interface, it receives that SNI packet, unwrap this packet, right? It will be unwrapped and it will display the result set. Whatever result that we sent, it will display the result set. This is how the select query works. So one point, let's say, for example, hmm, hmm. let's say, for example, I have two pages, for example. page 1, page 2. In this page, I have 1 to 100. So 1 to let's say 100 that I have. So another page, I have 101 to let's say 5,000, right? So I need this. Suppose if I need the data where it satisfies, let's say 1500 rows or whatever, like, 1500 rows, right? So 1500 rows I require. So what optimizer does? Optimizer take these two pages and store it in the, not optimizer, the buffer manager take these two pages and store it in the data cache. If the data which satisfies lies in that page, then it will take the page, entire page, and it will store into the memory, that is data cache, and it will proceed further with the execution, right? So this is how that is. Say any questions here or anything that you wanted to understand more here, at least the select query. This is a high level, like, so select query, whatever that works, right? SQL Server network, whatever I talk, so everything is same, right? So SQL Server network interface, the client establish a connection to the server network interface on the SQL Server using what of the protocol. It can create a connection to a TDS endpoint. So there will be a TDS endpoint, whatever I was talking, right? It will be converted as a TDS packets and it will send it back to the query parser. Query parser checks existing, so whatever the query plan exists, using query plan that matches the statement received. If it did not find that, it creates a query tree based on the select statement and pass it to the query optimizer, right? So the optimizer generates a zero cost plan if it is a trivial. The execution determines that data needs to be read to complete the query plan. It passed request and access method to storage engine. Whatever that I talked, like, so this is what it is, right? Access method connects to the buffer manager and checks the data is available or not, right? So this is what it is. Access method pass the results set back to the relational engine to send the client, right? So whatever um, select query is this, right? So any questions on this? So if you understand this select query, right? So based on this select query, uh, so even any of the operations, let's say, for example, if I'm using delete, sorry, if I'm using any of the DML operation, so everything will be depends on this particular operation, right? So if you have a clear understanding on this select, the same thing happens for the any of the DML operations. DML is nothing but insert, update, delete, whatever we proceed. So it will be same. Any questions on this? Yeah.
Uh, Chindu, so in buffer and data cache, whatever the information required in select command or it may be DML or DDL, so this data will be stored in form of pages, right?
Pages only, like whatever pages only, it will be stored in the data cache.
Yeah.
Hmm.
In case, like in select command, if we are using with where some ID is equal to,
Hmm.
okay,
Hmm. Hmm.
this ID, if it is not available in the sorry, if this once the select command is prepared by optimizer,
Hmm.
uh, and for example, where ID is equal to, I'm replacing with some other value. So I want to check with some other value. Still the optimizer uses the same plan.
Yeah, that's what, right? So that is what the intention was. If it is a similar plan, similar query, for example, let's say table where ID equal to 10. Same thing, select star from table where ID equal to 20. Let's say This is your question, right? So if
Yeah.
if you have the similar query, so I will talk one more feature within SQL Server. There is something called parameterization, right? If it is anyway, like if it is similar query, right? So similar query, then optimizer will use the plan, reuse the plan.
Okay.
One second, right? So optimizer, I mean, so again, like, so if it is similar, it will be using the same plan. So there is another thing that we have. I will talk that later, but we have so this is what we called as ad hoc query, right? So maybe I will talk. This is too much, but yeah, I will talk this later. But we consider this as an ad hoc query. Ad hoc query, the query optimizer will not cache for each and every query. If that is the case, every query, ad hoc query that we execute, it might go for recompile and generate a new plan. But as long as these two are identical, and it can go for, it can use the same plan. But we will talk that like what situations it can go for new plan, even if it is, so similar query. But to answer your question, it can use the same plan or it can go for another plan also. I'll show you that. One second. For example, I have two, right? So if I execute this using, I'll take the actual execution plan. I will talk that later, that don't worry. So if I go for XML, true. Okay, if I go for two. So this is two things, right? Let me go here. So two, right? So if you're using this similar query, right? So similar table, even if you use this, so two, right? So you see here, there is a difference. Though I have not provided any of the parameters. So this is converted as a parameterization. Though I have given two,
Okay.
I will talk, that's what I was talking, right? Parameterization. We have something called simple and forced parameterization. I will talk that later. I don't want to confuse here, but yeah.
Okay.
So
Okay.
it will be internally converted. Like even if you give this three, for example, see, still at the rate one, it is taking,
Hmm.
right?
Okay.
So this will be going, and if even if you see that cache,
As of now, I cannot follow because it's not a maybe I'm not very much clear about it. But I
uh,
understood that at the rate one is playing a role here.
I mean, so what I mean, like I'll show you this just a high level. If you scroll all the way down, if you see here, the compiled, I told you, right? The query will go for compilation. So the compiled value is taking one, whereas execution time, I'm using this three. So since I'm compiling the query with one, this is using the whole plan. I mean, maybe we'll talk that later. This is too much.
Yeah.
What I mean, in some cases, it will be using, if it is a simple trivial, then definitely it will be using the same plan, even if you use it different values here. But if it is a complex optimization, full optimization or complex queries, it will not use the same plan. That is considered an ad hoc query, and ad hoc query, every time it will be generated a new plan.
So if you are using a different values, also the cost of the plan at that moment will change. Keep on it will be changed, right?
If it is not using the same plan, it will be changing. But this one, right? So even if I use this one, it is using the same plan, the cost will not be changed. If it is two, the same plan, cost will not be changed. If it is three, the cost will not be changed. until and unless the query plan is changed, the cost will not be changed. The cost will be same for every execution.
Oh, okay. For a particular optimized plan, the cost will be same for multiple times or any times.
Correct.
Okay. Okay.
Execution time will be different, can be different. So you know what I mean, right? For example, let's say, for example, this is I am getting only one row, 10 rows, right? But if I use the same different ID, let's say, for example, 3, it can go for 100,000. Um, uh, so the execution time can be different, but yeah, the query cost, everything will be same if it is using the same plan.
So if the time is changing, obviously,
I mean, we will talk that later because that is the
okay,
reason I
okay.
just
Yeah, I think
cut it
even
down.
for me also it will maybe difficult. Okay,
Uh,
we will go accordingly and we will try. Actually, what happens is, sorry, I'm taking much time. I will close it
mm,
shortly.
mm, mm,
This particular topic is really a vast topic. Okay,
mm.
where to ask the questions and when to ask. If I'm not asking now, maybe later or in the later stage, maybe I may not be able to ask it also. So
Maybe you'll have to note it down because I totally understand. But so you are asking question. Let's say, for example, maybe I'm kind of curious and I'll jump into that answering questions
yeah,
and all. Maybe that is kind of
more
misleading and
complex.
so yeah, so misleading and it can be a warhead to people like who don't follow, right? So it can completely here and there will jump. So definitely you will ask. I'll also try to answer, but again, like that can go for different directions. So that is the reason we wanted to stick to the point like topic so that it would be helpful to everybody.
Yes, Chandra, thank you.
Right. So so I thought of covering the update as well. Like we have update, the similar until we have this access method, but I will talk this later tomorrow. Until this point, it is similar. So we have main two major things. One is transaction manager and one is lock manager and log manager. So we will talk that, and we will have some understanding, right? We'll have to understand what is write ahead logging. We need to understand what is checkpoint, lazy writer. So these are all things that we will talk later. So any questions, others? I know maybe I don't like, so uh, in if you have any questions or anything, but if you have any questions, we can talk tomorrow. We'll provide so the details, like whatever questions that you ask, like I'll try to answer. But if you have any questions, please feel free to stop and ask questions. And if it is out of this topic, I'll definitely say that we will talk it later. But yeah, if you have any questions,
Question.
yes, sir.
It's not it's not about what you taught today, but I just want to ask, what is the modality of the class? Is it going to be Friday and Saturday Eastern time and Saturday and Sunday IST only?
Uh, Both are same. I mean, Eastern, like the timings are the same time, like so Saturday, Sunday, IST 7 a.m. So it will be Eastern, I think 8:30 p.m. Friday and Saturday.
Only. Just 2 days out, right?
2 days, yeah, yeah, 2 days. Because I'm also working because I might not have much time to cover on weekdays, but I mean remaining days, I'm thinking of like so Friday and Saturday and Eastern.
Okay, because when the class about to start, you mentioned Monday or something. That's why I want to clarify that.
Did I
I don't
mention
know what.
Monday? I don't remember, but yeah, so it will be on Saturday, Sunday IST, and if it is US hours, it will be Friday and Saturday. If I mentioned that, sorry for that, but I don't remember. But
No,
yeah,
no,
so
that's fine. That's fine.
Friday and Saturday, yeah, Friday and Saturday for Eastern.
Okay, are we going to get the PPT?
I can share this, yeah. Not maybe I can share that as convert. I'll convert this as a PDF and I can share that
Okay, share.
end of the
Thank you.
class. Sure, thanks. Any other questions, anyone? If not, we can connect. I totally understand like people who are joining from US, maybe it's late, but we'll try to we'll see like what best we can do. But yeah, this is what we plan for.
It's 10:30 p.m. Eastern time now. So on Central Time it's 9:30 p.m.
Mm, yeah, yeah, yeah.
Well,
I
I'm
understand.
okay anyway. I don't know about any other person. I'm okay.
Okay.
So
Yeah,
yeah.
if you have any concerns, like maybe right, so that we will see, like, so maybe at least here and there we'll see that. But yeah, this is what we plan now, and we'll see that, so based on majority uh, members availability. Okay, so I'll stop recording here.